Lesson 5 and 6 is about rotations, which is the last isometry that we have to learn. So let's get down the definition of rotation, even though I know most of you probably already can figure out what that means. So rotation means to move a figure in a circular direction. Obviously, you're just rotating something. So let's take a look at what that would look like. If this is my starting image, this is my pre-image, and I want to rotate it, we need something else in order to decide where we're going to rotate it, because there's so many ways that we could rotate this. So just like how there is a vector for translation and there's a line of symmetry for reflection, there is your point of rotation for rotation. So you just need some point that says, hey, this is where I'm going to rotate it around. So this is the point where we can rotate this pre-image around. Now, if I want to rotate it, there's still a lot of things that we can do. It's going to rotate around this image, or around this point. Obviously, it's just like going around a clock. There's so many places it could end up being. The next thing we need is also then the angle of rotation. So that just says how far we're going to go. So let's say I'm going to go from here down to here. So this angle right here that I rotated from here down to here, that angle, that's our angle of rotation. Now, in this class at this grade level, we're not going to be too picky about, rotate it 30 degrees, because I know that all of us don't have those specific skills to rotate it, something like that, or even have the tools for it. So if I specifically ask you to rotate it, it'll either be of an amount of your choosing, or it'll be something really obvious that you know, like 90 degrees, 45, 180. Okay? So just understand, though, that the angle of rotation just tells you how much you're rotating it. Okay? So I'm actually now going to use Geogebra to show us some more examples. That way it's more accurate. Using Geogebra, I took this pre-image and I rotated it about this point. So here's our point of rotation. Okay. Now, it may not be too obvious to know how much I rotated it, but you can always figure it out. So if you draw a line from a point to the point of rotation, and then the point of rotation to the image to the rotated point, there's your angle of rotation. Okay, and in this case, I chose to do 45 degrees. Okay, now because I did 45 degrees, and I did 45 degrees clockwise, another way we could say that is that I did positive 45 degrees. Okay, you'll see sometimes in your book them say, oh, rotate something negative 45 degrees. That means just 45 degrees counterclockwise. Okay, so let's actually take a look at what that would look like. So here in our second one, this was the negative 45. This one's our negative 45, and this one's our positive 45 rotation. Okay. Let's take a look at some more examples. Here's another example of rotation. So I took my original image, this is my pre-image, and I rotated it about point E. Okay? Now, I rotated it 180 degrees, and it doesn't actually matter if it's positive 180 or negative 180, because it'll actually end up being the same. it's going to still end up being over there because whether we went this way or this way, it's still going to end up over there. Okay? One thing you might want to notice with rotation, just like with reflection, is however far our pre-image is from our point, that's also how far our image is going to be at the end. And I can show you this actually using our tool Geogebra. So take a look at the screen. I'm going to move our pre-image, and you can see that however far away or however close I am to our point, that's also how far or how close our image is going to be. You can even see with this one, no matter where I go, because it's 180, our image is always on the other side essentially. Now, when we rotate something 180 degrees, there's some interesting things that happen with the lines. And it may not be completely obvious, especially unless we extend them out. So let's take a look at what happens if we extend out this line, oops, and that line. So here what I did is I extended out BC, just going on, and I extended out B prime, C prime, going out. Now what do you notice about those lines? Those lines are parallel. So let's get this down, and then we can do another example to make sure it's really true. A line segment 180 degrees. A line segment is parallel to its image if rotated 180 degrees. Okay, so this guy is parallel to that guy because we rotated 180 degrees. Let's take a look at another line on here and see if that holds up. Let's try this line and its image, this line. So first I'll get rid of the other line so it's not distracting. So once again, let's take a look. Those lines are the same distance away no matter where you are, and that's the definition of parallel. So yeah, this holds true. A line segment, so the original line segment, is parallel to its image after it's being rotated 180 degrees. Now, is there anything else that could be special about if we rotate some things a certain way? Well, let's take a look. Here we have another example where I actually rotated the original image by this point 90 degrees. And I actually rotated it counterclockwise, so it's technically negative 90 degrees. So if you want to look at our angle of rotation, it's like that. Now, let's take a look at if there's any specialties that happen with our line segments. We just saw that when we rotate something 180 degrees, the line segments become parallel. Well, let's see if there's something special that happens with these line segments when we rotate something 90 degrees. So I'm going to start by looking at line segment BC, and then we'll take a look at B prime, C prime, and see if there's anything interesting about those lines. So I'm going to extend out those lines and then we can take a look. All right, there's our lines extended out. Is there anything interesting going on about that? Like maybe what angle they cross each other at? If you take a look at this, that right there is a right angle. Could that be true all the time? Let's write this down first and then we can check if it's correct. A line segment is perpendicular, meaning crosses at a right angle at 90 degrees to its image if rotated 90 degrees. And it doesn't matter if it's 90 degrees clockwise or counterclockwise. So let's look at another line and see if that holds up. We're now going to look at AB and A prime, B prime. And let's see if those ones are also perpendicular. So let me take off the old lines. And do those look like they're perpendicular? Yeah, those look pretty perpendicular. That looks like a right angle right there. So yep, this holds up. A line segment is perpendicular. So this line segment is going to be perpendicular to its image if rotated 90 degrees. And that's all that I'm going to be showing you for rotation. We'll be doing a lot of practice in class.